For this problem, we have a NAND gate with 8 inputs, and we need to build this. For each of the following cases, we need to minimize the number of gates used in the multiple level result. So for part A, we're going to design the 8 input NAND gate using 2 input NAND gates and NOT gates. So we can only use these things, NAND and NOT gates. We're going to start off with A right here. We know that we are going to have an 8 input NAND gate. So that means we are going to have a NAND gate here. And to draw a NAND gate, you're going to draw 2 input sticks. I call them sticks. And then you have this kind of curve. You have a dot here, and that represents a NAND gate. An AND gate, and this is A and D, not what we're drawing, but the opposite of what we would be drawing. And AND gate is basically the same thing, just not with the dot. The dot represents a logical NOT. And we'll see that with the NOT gates as well. So we have these NAND gates, and those are 8 input NAND gates. So we've satisfied the first part. Now we're going to use 2 input NAND gates, but we're also going to use NOT gates. And well, to do this, we can put NOT gates like this. However, I'm going to show the actual kind of thought behind this. If we have NAND gates, we know the output of a NAND gate is going to be 1, 1, 1, 0, and we have 4 of these. But I'm just going to make 2. So we have 1, 1, 1, 0, and then this is our NAND, right? And we're doing this 4 times, so we'll just times this by 2. Now, if we were just to continue, right, and we were to connect these with a NAND gate, and then connect these with a NAND gate, and connect these with a NAND gate, we would be able to solve for this. However, we have nowhere to put our NOR gates. So what we can do instead, since we know that, we just demonstrated, that we can put a NAND gate here, and then we can put a NAND gate here, and then we'll connect these with some kind of NAND gate. We can do that. So the NAND of these 2 NAND gates would be 0, 0, 0, 1, and then we would have 0, 0, 0, 1, and this is just these 2. And that's if we have only these NAND gates, and then we know we are terminating into one last NAND gate out here, so we would have 1, 1, 1, 0. And so this is a NAND, and since these are NANDs, and we started with this, we've kind of solved for this. However, we need to include the NOT gates. So to place the NOT gates where we'll still get the same output, we can place them right here and right here. That way they'll kind of, in a way, say cancel each other out, and they won't change the output. So let's look at this. We are going to connect a NOT gate right here. We're going to do the same thing right here, and then it's a little bit wonky because of how it's drawn, but basically it's a triangle with a dot because it's a NOT, and then it connects to the inputs of our next gate. Now if we do this, we have a NOT gate here, and a NOT gate is basically the opposite of our inputs. So that means we're going to have 0, 0, 0, 1, 0, 0, 0, 1 times 2. And so a NAND gate, basically, when we have the 2 inputs as 0, our output is 1. Because an AND gate, and this is AND with an A at the beginning, we know an AND gate, if we were to look at this NOT as our input, and the AND gates are output, we would have 0, 0, 0, 1. So a NAND gate, which is the opposite of an AND gate, would be 1, 1, 1, 0. So knowing this, we can look at these 2 NAND gates, and we're going to build them. Or we're going to make a small little truth table here. So we have our NANDs here, and for both of these NANDs, we are going to have 1, 1, 1, 0, 1, 1, 1, 0. Now, this is an AND, but we can't stop here because, well, these two aren't connected. And so to connect them, what we're going to do is we are going to have a NOT gate right here, and we're going to have a NOT gate right here. So these will connect to this output, or this input, sorry, and then we can write a little truth table here. We have NOT, and now we're going to be looking at this. These are our inputs, and so the output would be 0, 0, 0, 1. And now this last NAND gate, we will look to this as our output, and we can see the NAND of our two NOT inputs would be this. And so this would be the series of gates that we would use for part A. Now we're going to look at part B. So for part B, we'll do it up here. We're going to design the 8-input NAND gate using 2-input NAND gates, 2-input NOR gates, and NOT gates, but only if needed. So we're going to have the same thing that we had in part A. We're going to start this off with 4 NAND gates because we need 8 input NAND gates. And so our input is going to look like this. Now what we're going to do is, well, we're going to say that all we need is the 8 input NAND gates, which we have. We're going to use 2 input NAND gates and then 2 input NOR gates. So when we look at this, our output here, or I'm sorry, our input here is going to be NANDs, and we're going to have 1, 1, 1, 1, 1, 1, 0, 0. And then we want our final answer to be a NAND, and it's going to be 1, 1, 1, 0, 1, 1, 1, 0. And so somehow we have to get to a NAND right here. Now, in the middle of this, we know that we need 2 input NAND gates and 2 input NOR gates. So let's try this out. We can have a NOR gate right here and right here. So we will have our NOR gates like this. And a NOR gate, well, if we connect these like this, it's just going to have kind of like a curve, and then it's going to have this part, and then this terminating part right here. We're going to do the same thing here. This curve, this bulb looking thing, and this terminates here. That means what we're going to have is this NAND gate right here. So I drew it a little bit too far, and so what we can do is just move, or take this, move it over here, and then connect them. We have a NOR gate here. And a NOR gate is basically the output is 1 whenever it's opposite of OR. So basically, if we were looking at this NAND for the input, NOR is the output, we would have 0, 0, 0, 1. And since we have 2 of these, we would have 0, 0, 0, 1. Keep in mind for the NAND, we have 2. And so if we take the NAND of this, and I'm going to erase this so we can redo it properly, we are going to have NAND, and the NAND of 2 0 inputs is 1. We're going to have 1, 1, and then 0. And so we've done it. We've gone to a NAND gate at the end using the 8 input NAND, 2 input NAND for the end, and then the 2 input NOR. And so part C, it's asking us to compare the 2 gates used in part A and part B. And well, the gates used in part B are less, and we get the same output. And so that's the end of this problem. That's how you would go about kind of thinking about solving for it.